So welcome everybody to AssetBook's webinar. Today's topic is connected lighting and beyond. We appreciate you taking the time out of your hectic schedules. We know everybody's got lots to do. So let's just dive into the topic. So quick intro into lighting as a journey. You can see that it came quite a long way through various different guises, until more recently it found its guise as the LED lamp, and we've seen lots of developments around that. When, for the purpose of the webinar, I was asking myself, when did light get intelligent? And the answer, all the way back in 1906. Maybe not the intelligence that we're all thinking about today, but interesting all the same. When did lighting become wireless was the next question that I went into the great machine that is Google and asked. And apologies, I got the right answer to the wrong question. So the above occurred in 1893, which absolutely amazed me. But my question, I guess, should have been, when did it become wireless for controls? And I think the answer may well vary, but let's start somewhere. I got this from the Casambi website, and Casambi were at the front of wireless communication via Bluetooth, or as it was known in 2006, Wi-Bri. And they're now widely regarded as the world leaders in wireless lighting. And I guess another point to note from the slide was where the term IoT was actually coined, when and how. And that was obviously by a Procter & Gamble executive back in 1999, when they discussed the use of RFID. The next thing to note, I think, was that in 2016, we saw connected devices exceed 5 billion, not counting phones and tablets. I mean, a crazy number. And for a little bit of further context, it reached 15.1 billion last year and is predicted to reach 29.5 billion by 2030. I mean, staggering numbers. So connected lighting is good, brings many benefits and is popular. But there has been a problem with lighting and connected lighting historically. It's one of the many traditional silos that were created. Because, well, for various reasons, because the giant corporations didn't play nicely. Technology was an issue. The concrete thinking of each industry, and maybe a fear factor. Proprietary technology and communication methods. Expertise or lack of it, and more, there are many more. But lighting or any connected device is just a small cog in a bigger wheel. And best-in-class solutions should be just that. They should work in tandem with other disciplines or sub-solutions. Yeah, the most useful and powerful solutions will incorporate best-in-class technology across multiple topologies, probably, and maybe multiple communication methods too. So in this instance, a great pictorial just to show a few options in a unified system. Casambi lighting using a DALI protocol, which is a standardized protocol. Bluetooth controlling the HVAC and sending information. Wi-Fi people counting, pushed maybe through a REST API. Zigbee doing indoor air quality as an easy mesh. LoRa for the waste management, so you can have a wider area network. And then you could have cellular for vehicle tracking, so that if you had a national staff, driving all over the country, then they could also be part of this system. I can almost hear people saying, that's been happening for years via a BMS. But it's different now, and the architecture of today's new systems are way more future-proof. They're more capable and they're more powerful in the hands of those who use them. We no longer need serious coding and integrators and training. Just going back to lighting, so just to clarify, I guess emergency will always be a safety critical system, so it will stand alone. But in terms of control and authorization, or in added control, it could still be unified. Lighting can be a powerful part of any future ecosystem because it's already pervasive everywhere, and therefore often it exists already. So it can become part of the real estate for what's next. The power's there, the infrastructure's already there. And the ecosystem play, we believe, is inevitable. So why not lever it as a business using lighting? So let's take an example from a recent gym chain where we did an install. And how can lighting build into an end-to-end solution rather than just being a part of it? So we had the paddleboard courts, or pickleball as they call them in other countries. You can add a QR code. Everyone knows how to access a QR code. A booking system so that someone can book the time they want to play now or in the future. They can make a payment without leaving the platform. They can unlock the court and power up the main lighting. Maybe we could count the people to ensure that they're not just booking it to have a massive party and have 50 people in there. And also, we can use the data that we collect to find out if it's 2 people or 4 people, how many people generally book. We can put some sensing in there for noise so that we can ensure that there's no antisocial behavior, so everyone else has a great time as well as the people on that court. We can add a speaker, a klaxon, a strobe, anything really, to provide information, to warn of the end of the session, to tell people the session's begun. And all of this could be created easily. But what else could we add? We could add rental of paddles or balls using lockers, more smart technology. We could add vision cameras, record the games, sell them back to the users. Some people might want to see their own performance. We could put advertising boards around the side, and they could be operational only at the beginning or the end of the session, so that we could tell people the benefits of services that we also offer. So there's lots and lots of ways that we could take connected lighting beyond, a basic on-off function. So let's look at a second example for educational facilities and to tackle the growing issues of vaping and the safeguarding issues that follow around that. Smart vape alarms exist, but a more end-to-end approach could be flash the toilet lights to warn when the alarm goes off. When the vape alarm is triggered, we flash the lights in the toilet to let the users know they've been rumbled. A camera outside the toilets to capture the culprits, so that there's an educational approach to this in terms of how we safeguard. We could also make sure that the lights outside the toilet are on at full capacity so that we make sure we get good images. Then we send a paper plane to someone. No, hang on a minute, we don't send that. We're a technology company. So we can send a message or an email to somebody, the Senko maybe, or the person responsible for the safeguarding. And all the triggers could be sent to a file and recorded so that they can be accessed, so that there can be some educational use afterwards. The data can be analysed to help educational support, to find out how many times the problem has actually arisen, how pervasive it is. There could be reports for governance across multi-sites, across the whole country. It could be then taken into a study so that we can find out how bad vaping is for young people and how big a problem it is. So I showed two examples of what could be hundreds of examples, and it's clear there's significant opportunities to elevate the services that lighting manufacturers, suppliers, or designers could offer. Wider solutions, new services, less silos, more value. I guess, the word of caution, less suppliers. It's obvious that those across other disciplines might have the same idea to connect more services. And that could mean you could be squeezed out of supply chains as they're streamlined when more people take on more functions. And finally, we get more meaningful data, because if we can get all the data into one spot, we can work out how that data works across the platform, across all those devices, and see how we can make incremental gains. And things that would help to make those ecosystems more powerful would definitely be open standards, solutions at the heart of decisions, productized IoT approach, the unification software and middleware, and obviously all of our imaginations. And now I'm going to hand over to Dan, and he's going to show you a little bit more around the technical element, how and why you might use AssetBook to deploy beyond lighting. Are you there, Dan?
Hello, sorry, I was struggling to unmute myself there. You just jump back on. Hi, everybody, and thanks for joining us, and thank you, James. So we're going to take a look at how connected devices and smart services can come together to provide operational advantages. Lighting, of course, represents one of the most mature sectors of the IoT, with connected lighting having been commercially deployed for some time now. We'll take a quick look at how a platform like AssetBook can leverage some of the newer developments in connectivity in smart devices, and of course, how it fits with developments in the lighting sector. So just to take a quick view of the common approach to lighting and connected services. At present, you might have a specific protocol like DALI, managing some specific tasks such as general controls or emergency lighting. In some of the hybrid installations we come across, hybrid being coined quite prevalently now in lighting controls. This could be a mix of with manufacturer-specific lighting, maybe something like using a protocol like Bluetooth. These systems or devices might have some manufacturer-specific products, processes, or capabilities that are unique to this silo. And then you may have some of your non-specific lighting smart devices. These smart devices could contribute valuable data and insights into other silos, such as the effect of ambient temperature on LED driver lifetime, or specific occupancy data to improve lighting efficiency and prolong usable product life. These devices could also be used to collaborate these devices could also be used to collaborate performance in other silos. Historically, however, as James alluded to earlier, it's been very complex and expensive to pull data from these silos, and more complex still to have them autonomously work with each other. The rapid growth of the Internet of Things and smart or connected devices means that we have more choice now than ever before when selecting communication protocols, manufacturers, and hardware to perform specific tasks. We now have quite a few commercially accepted harmonized protocols which cover broad bandwidth and range requirements for local and wide area network, while cellular structures offer further connectivity possibility. Most of these network protocols require, we mustn't forget, obviously, standard wired ecosystems like Ethernet or PoE. Most of these network protocols require connectivity hardware such as gateways or routers, except for the case of cellular connectivity where infrastructure is managed by network operators. With all of these methods of connection, there comes a vast array of smart devices to choose from. Lighting is the obvious one within the built environment, but many other different smart devices are available, such as connected HVAC, smart meters, sub-metering devices, connected power sockets, a vast array of environmental sensors, asset or vehicle tracking, camera and vision devices, and even local EV charging infrastructure, just to name a few of the more popular applications. But what do we need to do to get these devices working together rather than in their silos? So once you've selected your devices, and these may be grouped by communication topology, manufacturer, or asset type, you'll need a few services to unify these. At this stage, it's important to note that some manufacturers might require cloud-to-cloud integration as they have some IP or unique performance aspect that are serviced by their own ecosystem. The service layers that you need from here are the networking layer, the ability to communicate, decode, and manage networks and data. The processing layer, where data is normalized. This is the process of organizing data after acquisition in such a way that the results of using the data is always unambiguous. Uniformity is key here to ensure relational data across all sources. In this layer, you'll also require secure storage of that data and the ability to integrate and perform analysis. This is the layer where metadata is added, the data that gives information or context to other data. In lighting, this could be the lifetime of an LED fitting, which could then be related to the burn hours of the device in the real world to calculate predictive replacement or service schedules. Finally, we have the application layer, how users or devices access and interface with that data, and where smart functions such as automations are created and executed. There are various service providers that will offer elements of these IoT layers, and luckily, as an end-to-end IoT platform, AssetBook encompasses all of these elements. So let's take a quick look at how it comes together with one of our ecosystem brand partners, Casambi. Casambi devices can be commissioned, locally controlled, and modified on the Casambi platform and connected to the internet through a gateway. Cloud-to-cloud integration with AssetBook means that we can visualize and control the system remotely, but with all the incoming data being normalized in AssetBook and the inclusion of metadata added to these devices or parameters, AssetBook services, such as the ones you see here, are easily deployed. Customized user access, permissions, and functions enable more stakeholders to engage with the system and ensure efficiencies in operation. Finally, all other AssetBook modules can then form part of the same ecosystem, allowing for unified control, deeper insights, and collaborative technology to be deployed and managed in one place. So let's take a look at an asset on AssetBook so we can understand some of the concepts of data normalization and categorization we've been talking about. So once connected to AssetBook, data is normalized and presented uniformly. So these are the parameters that are being reported by the device, all being normalized into a single point. Additional data can then be added to the asset for maintenance, performance, calibration, compliance, etc. Think battery specs for emergency, specifications for lighting products, point of sale information, etc. Location, zones, tags, linked assets, these are all ways to have individual assets work part of a subset or group. And of course, once all the data and assets are normalized within your asset ledger, being able to link them and group them is relatively easy. And finally, individual warning and alarm thresholds can be easily set for any of these harmonized parameters. So we can very, very quickly select the elements of the product or the information that's important to us and ensure that we have live information on these. If we zoom out from the individual devices, you'll see the asset ledger, a comprehensive list of connected devices. In this case, some Casambi fixtures, lighting fixtures, but equally these could be LoRaWAN sensors and a combination of Zigbee sensors as an example. The assets are then geolocated and grouped, tagged, and linked as appropriate. With this granular approach, assets can be easily consolidated by asset type or class and by location, area, room, floor, building, site, city, etc. This gives great scope to understanding the operational performance from a top level all the way down to the device level. Nothing really new for lighting controls, but when combined with all of the other asset classes and types that can be fed into a single point, quite powerful. This topology also means that modification or alterations to installations are easily realized in AssetBook and require little effort to remodify or regroup. If we zoom out a little bit further, we will see the site view where items are grouped by a wider area. This would represent a single tenancy with a multi-site approach. Let's take a quick look at the visualization elements. We have all this data, it's been normalized, and various components are offering their different views on what's going on in the physical world. Dashboard allows you to take any parameter from any device or any parameter from any virtual asset, the weather forecast or spot price of energy, for example, and compile these into user-specific formats. While alarms and notifications can be used to inform on events, the dashboard view offers real-time information on what's important to the end user. As AssetBook is a no-code platform, these dashboards can be created easily with the use of widgets and tiles that can be modified in seconds. Reports can be pulled directly from the dashboard view, with all elements being interactive and historical data downloads at your fingertips. Analytics is the systemic computational analysis of data or statistics. It's used for the discovery, interpretation, and communication of meaningful patterns in data. In simple terms, analytics allows you to overlay and combine various data points to deliver consolidated information, as you can see here, where granular data can be combined into key metrics and reporting structure. For example, energy consumption across lighting, HVAC, and distributed power grouped by location. In this instance, we have added ESG metadata to relate the reported figures to key sustainability metrics. Analytics can also be used to create key combination reporting structures, which can then be included in dashboards and reports, and can form a valuable component of operational intelligence. Any data can be compared and visualized to offer key insights into things like performance, efficiency, compliance, comfort, safety, and cost reductions. Automations forms another key component of a harmonized system architecture. The purpose of these is to reduce human intervention in process, mainly by predetermined decision criteria, reduce the demand for human review of operational data, collate and present data based on specific scenarios, including notifications and alerts for defined circumstances. The more data points and devices connected to the network, the greater the value that can be derived from automations. AssetBook, as a no-code platform, allows users to simply and quickly create and adjust their own automations by selecting any parameter from any device that's connected to AssetBook or any virtual parameter to create intricate scenarios and subsequent actions and outputs. So here we have an emergency lighting application. Let's take a theoretical look at how we can use our system to improve its performance in an emergency situation. So emergency lighting duration test is due. Desk and room occupancy sensors could be used to ensure the area is unoccupied at the time of the test. We can use metadata, such as the time of day, to ensure a test is only run when occupancy is not scheduled for an appropriate period afterwards. So if we're running a 3-hour duration test, we can use metadata to ensure that it's at least 3 hours before any occupancy is there. There is obviously the element that it shouldn't really be occupied 24 hours after a duration test, so we can apply the same there. Shades could be closed to reduce natural light during a test. And the reason for this is we could employ independent sensors to record physical performance of the test and combine it with test reports, i.e. lux sensors reporting on the level of light during the test at desk level to ensure compliance, for argument's sake. And we can even use energy consumption during and after the test to analyze luminaire performance, battery recharge rates, efficiencies, etc. Let's take this a stage further and have a look at some lighting devices. So here we have an emergency lighting application. Let's see how we can improve it through the use of IoT. Let's make these emergency light devices smart and create a mesh network and connect them to the cloud via a gateway. Now let's add some sensors to these devices. These could be super low power sensors like CO2 sensors, temperature, occupancy, or with upgraded battery capacity, we could add vision cameras to these devices. Like the fittings themselves, these could be maintained or non-maintained in respect to their operation. That is to say, they could be set to only work in case of emergency. For the purpose of this example, let's give the gateway cellular backhaul capabilities. Now, in the instance of a fire or an emergency, say, there could be a fire switch on site, which would allow the emergency response secure access to the system via cellular connection. Here, you could present blueprints of the site with heat map for areas of concerns, excessive CO2, heat, occupancy, for example, up-to-date floor plans of the site, individual or collated sensor data to identify key metrics on the environment, excessive CO2 in certain areas, for argument's sake. Or in our case, even a live feed from the video cameras themselves during the emergency situation. All of this data could be fed through an AI engine in an emergency situation to highlight key areas of concern automatically, or simple automations could be set up to highlight these. For example, emergency mode plus occupancy in an area plus high CO2 plus high temperature equals a priority. I hope some of the points addressed here are thought-provoking and you've enjoyed a brief review of how the IoT sector is impacting on traditional lighting. I'll pass back over to James now, who will open up the floor to any questions you might have. Thank you.